On October 3rd, 2025, many spacecraft at Mars are pointing their cameras at something that should not exist. An object is ejecting 150 kilograms of gas per second, with no counterthrust, like watching a cannon fire with absolutely no recoil. Violation so fundamental that when scientists first saw the data, they assumed their equipment was broken. It was not. Aviluf of Harvard rated it a 6 out of 10 on his scale for alien technology. But that is not why you are here. You are here because 2 days ago, someone claiming to work for the European Space Agency revealed something in 4 detailed and frustrating technical pages. They describe an official task force that tried and failed to classify this object as any known type of natural celestial body. Quote, "This position is no longer tenable," and the silence from leadership about the cognitive dissonance that this requires is becoming a serious professional issue. They speak of chemical reactions that should be impossible. Nickel tetracarbonyl, a synthetic industrial compound, is spraying from a rock thought to be billions of years old. The dust was so strange it took a week of recalibration before they accepted the measurements as real. And a problem of mass. 33 billion tons compressed into 3 kilometers. A statistical probability so poor that either our models of the galaxy are wrong by a factor of 10,000, or this object is not debris at all. But here is what makes it worse. In 26 days, it will disappear behind the sun, a perfect window to hide from every telescope on Earth, and when it returns in December, we will know if it has changed course, because if it has, nothing natural can explain that. There is one theory, a theory that sounds like science fiction, but which explains every single anomaly: a thrustless outgassing, synthetic chemicals, thermal impossibilities, an object with its own internal engine, not powered by the sun, but by something from the Big Bang itself, and it is testable. 2 predictions. Both could be dismissed, and both will arrive within the next 3 months. This is by Atlas, the 3rd interstellar object we have ever discovered, and the first to make scientists wonder if they are looking at a comet, or something disguised as a comet. When you finish this video, you will understand why some researchers are no longer sleeping well, why its trajectory seems designed, why the timing is so perfect, and what will happen if the data continues to refuse to cooperate, because the walls are cracking and the shape of the room is beginning to emerge. If you are ready, press the like and subscribe button, because this story is unfolding in real time. And let me know in the comments where you are listening from, what time it is there, and the strangest thing that has ever happened to you. Chapter 1. The Mars Moment. Something is happening right now, not tomorrow, not in some distant future scenario where we finally build the right telescope or send the right probe. Right now, today, October 3rd, 2025, at this very moment, humanity has multiple spacecraft positioned around Mars, and every single one of them is trying to photograph the same object. That object is called by Atlas, the 3rd confirmed interstellar visitor to our solar system, and at 4 a.m. Universal Time, it passed within 29 million kilometers of Mars. That is the closest it will come to any planet. During its journey through our cosmic neighborhood, the timing is critically important. Let me explain. For the past 3 months, scientists have been observing this object with ground-based telescopes. Hubble has photographed it. The James Webb Space Telescope has analyzed its chemical signature. Tens of observatories around the world have tracked its movement. But there is a problem with all of that data distance. When Hubble photographed by Atlas on July 21st, the comet was 446 million kilometers away, which is about 3 times the distance from Earth to the Sun. At that range, even Hubble's incredible optics could only resolve so much detail. But today, one thing had changed. The Mars Reconnaissance Orbiter, equipped with the high-rise camera, was now 20 times closer to BAI Atlas than Hubble was during its observation. 20 times. The difference in resolution was astonishing. Where Hubble could only see a fuzzy blob surrounded by dust, HiRISE would be able to resolve details down to 30 kilometers per pixel. If this object was truly as large as some calculations suggested, 5 kilometers or more in diameter, we would be able to see structure, shape, and perhaps even surface features. The European Space Agency was also involved, with 2 spacecraft turning their instruments toward the comet. Mars Express carries the high-resolution stereo camera, and ExoMars has the color and stereo surface imaging system. Both were designed to image the Martian surface. But during this brief window, they were aimed at something far more unusual. And then there were the spectrometers. Mars Express has Omega and SpikeAM, and the ExoMars Trace gas orbiter has Nomad. These instruments don't just take pictures. They measure specific light. They split the light reflected or emitted by an object into its component wavelengths, and that data reveals the chemical composition. What molecules are present? What are the prevailing temperatures? Is the activity we're seeing caused by sublimating ice or something else entirely? The hope, the official hope, was that these observations would settle some fundamental questions. How large is its nucleus? Really? Is it rotating? And if so, how fast? What does the dust cloud actually look like up close? And most importantly, is this just an unusually large comet behaving in unusual ways? Or is there something fundamentally different about this object? Because this was the tension, based on brightness alone. When BAI Atlas was first discovered in July, astronomers estimated it could have a diameter of up to 20 kilometers. Then, as better data from the Vera Rubin Observatory came in, that estimate dropped to 10 kilometers. Then, Hubble observations in late July suggested perhaps 5.6 kilometers, and some models, depending on how reflective the surface was, suggested it could be as small as 440 meters. That's a huge range, from 20 kilometers down to under half a kilometer. That's the difference between a small city and a large building, and the answer had huge implications. If BAI Atlas was indeed 5 kilometers or more in diameter, it would become the most massive interstellar object ever detected, far exceeding it by several orders of magnitude. The first interstellar visitor, Oumuamua, was estimated to be about 100 meters wide, shaped like a pancake, tumbling through space. The second object, Borisov, was perhaps 600 meters across, a relatively normal-looking comet. But that 5-kilometer, 33-billion-ton object is not just large. It is also a statistical problem. Let me put this into context. Our current models of how interstellar objects form suggest that smaller fragments should vastly outnumber the larger ones. For every single mountain-sized rock ejected from a solar system, far away, there should be tens of thousands of pebble-sized fragments, maybe even hundreds of thousands. The probability of detection is heavily skewed toward the smaller objects appearing first, simply because there are so many more of them. And yet, here we are. 3 interstellar objects have been detected so far, and the third is potentially more massive than the first, by 1,000,000 times. That is counterintuitive, unless our models are wrong, unless the galaxy is not just sparsely populated with interstellar debris, but is teeming with it, unless the processes that eject material from solar systems are fundamentally different from what we think, or unless this object is not debris at all. That is the question that observations from Mars are supposed to help answer. If HiRISE captured a clear image showing a 5-kilometer nucleus, the mass estimates would hold, with 33 billion tons becoming a solid floor. And at that point, the statistical anomaly becomes unavoidable. If the image showed something smaller, say 1 kilometer or less, then the mystery shifts, because a smaller nucleus with the observed brightness and outgassing would mean this object is extremely active, ejecting more material than any known comet at that distance from the Sun. Either way, something does not add up. Now, here is the disappointing part. We will not know immediately. The data has to be transmitted back to Earth. It has to be processed, analyzed, and cross-referenced. The European Space Agency has stated that they do not expect spectacular images from the Mars Express and the ExoMars Trace Gas Orbiter. Both spacecraft were designed to look down at Mars, not out into space. At a distance of 30 million kilometers, Comet Atlas would appear smaller than a single pixel. In their cameras, they might be able to capture the coma surrounding it, maybe a hint of a tail, but not the nucleus itself. High-rise was the real hope, and even then the timeline was uncertain. A few days, maybe a few weeks, before the processed images would be released. And in that gap, the object would continue its journey until mid-October. Comet Atlas would be too close to the Sun to be observed from Earth. The glare would render it invisible. It would reach its perihelion, its closest point to the Sun, on October 29th, at a distance of 1.4 astronomical units, just inside the orbit of Mars. And during that entire period, from mid-October until the end of the month, the object would be on the opposite side of the Sun from Earth, obscured, unobservable. That's 26 days, almost a month. And when it re-emerged in early December, gliding into the pre-dawn sky, we would finally be able to see it again, check its trajectory, measure its brightness, confirm whether it had behaved like a normal comet during its perihelion, or if something unexpected had happened. But let's return to today, October 3rd, the Mars moment, because while the official story was focused on resolving the question of size, there was another layer to this story, a layer that had less to do with what the cameras would capture, and more to do with what the data was already showing. And that's where things started to come apart. Chapter 2. 7 Sins Against Nature. Avi Loeb published a paper on October 3rd, the same day as the Mars flyby. The timing was intentional. In it, he laid out what he called the 7 anomalies of Comet Atlas. Not ambiguities, not curiosities, but anomalies. Behaviors and characteristics that did not fit the model of what a standard interstellar comet should look like. He divided them into 2 categories. The first category contained 4 anomalies that could be explained or resolved with better data. The second category, 3 anomalies that, in his words, would forever remain a puzzle because they weren't about missing information. They were about probability, about trajectory and timing, suggesting something more than mere coincidence. Let's begin with the first category, the explainable ones. Anomaly 1, its size. We've touched on this. The diameter of BAI Atlas seems to be greater than 5 kilometers, giving it a minimum mass of 33 billion tons, which makes it over 1 billion times more massive than the 2 previous interstellar objects. The potential explanation here depends on whether future observations like today's Mars flyby will confirm or revise that number. If the cometary nucleus turns out to be smaller, the anomaly lessens. But if it is confirmed to be 5 kilometers or larger, the statistical problem deepens. Anomaly 2, the jet. As images from Hubble reveal a peculiar feature, a long, forward-pointing jet of scattered sunlight, 10 times its width, pointing directly towards the Sun. Most comets have tails that stream away from the Sun, driven by solar wind and radiation pressure, but this jet is different. It points in the opposite direction. The proposed explanation is that BAI Atlas experienced a powerful outgassing event on the side opposite the Sun, releasing material that reflected sunlight before being pushed back. All right, that seems plausible, but here's the catch. The jet appeared early, at distances where most comets are still dormant, and it remained unusually bright and persistent. A faint tail did appear in late August, but only after the object had moved significantly closer to the Sun. That delay is strange, suggesting the outgassing dynamics are not behaving like those of a typical comet. Anomaly 3 chemical composition. This is where things get truly strange. Spectroscopic observations from the James Webb Space Telescope and the Very Large Telescope revealed that the gas cloud surrounding BAY Atlas contains more nickel than iron. In typical comets, and even in the previous interstellar comet, 2I Borisov, nickel and iron appear in similar proportions to what we see in the Sun, almost in balance, but BAI Atlas shows an extreme dominance of nickel. Nickel was detected at every observation point, while iron only appeared when the object was closer than 2.64 astronomical units from the Sun, and even then, the ratio of nickel to iron was much higher than expected. Why does this matter? Because nickel and iron are refractory metals. They do not sublimate, changing from a solid to a gas. At the low temperatures on the comet, the surface temperature of BI Atlas, even when relatively close to the Sun, was too cold for pure nickel to vaporize. Something else had to be happening. Either there was a parent molecule, a nickel-bearing compound that was breaking down and releasing the nickel atoms, or a non-standard heating mechanism. Either way, it was puzzling. And what is more, the gas composition was also unusual. Most comets are rich in water as they approach the Sun. Water ice sublimates and dominates the spectrum. But BI Atlas was rich in carbon monoxide. The ratio of carbon monoxide to water was 8:1. That is one of the highest ratios ever recorded. It suggests this object formed in a very cold environment, much colder than the regions where typical solar system comets originate. Anomaly number 4. Polarization. This is technical, but important. When light reflects off dust particles, it becomes polarized. The degree and direction of polarization tell you about the size, shape, and texture of those particles. Every comet and asteroid we have studied falls within a certain range. Predictable, consistent, BI Atlas did not. The polarization data came back way outside the expected range, so much so that the team initially thought there was an error. They repeated the measurements, and the result was the same. The only way to explain the numbers was if the dust particles were fundamentally different. Not the typical silicates, not water ice crystals, but something else. Large, complex, highly porous particles, with a structure almost like smoke. Now, here is the key point. These 4 anomalies are strange, yes, but they are not necessarily fatal. To the comet hypothesis, better data could clarify the jet size. The outburst could be a rare but natural outgassing asymmetry. The nickel could come from a strange parent molecule we have not yet identified. The dust could be the product of unusual formation conditions. Uncomfortable, but explainable. Then, we come to the second category, the permanent mysteries. Anomaly number 5. The orbital alignment. The orbit of BI Atlas was aligned with the ecliptic plane to within 5 degrees. The ecliptic plane is the flat disk where the planets orbit the Sun. Most interstellar objects arrive from random directions within the galaxy, and will have random orbital inclinations, some steep, some shallow, some in retrograde motion. The probability of an object arriving on an orbit nearly aligned with the planetary plane by pure chance is about 0.2%. 1 in 500. Now, that is not impossible. Rare events do happen, but that is the first red flag. Anomaly 6. The arrival time. This is where the probabilities fall off a cliff. BI Atlas did not just arrive on an orbit aligned with the planets. It arrived at a time that allows for close encounters with Mars, Venus, and Jupiter. Specifically, the object will pass by Mars today, October 3rd. It could have reached Venus with a minimal course correction in July, and it is positioned for a relatively close flyby of Jupiter in March of 2026. The probability of a random interstellar object arriving on an orbit, and at a time that allows for such encounters, is about 0.005%, 1 in 20,000. Think about that for a moment. If you were designing a probe to visit multiple planets in a solar system, you would want an orbit that intersects their orbital paths. You would time your arrival to coincide with their positions. You would minimize the fuel needed for course corrections. This is exactly how we design human missions. Voyager, New Horizons, optimizing trajectories using gravity assists. B.I. Atlas looks as if it was delivered. Chapter 3. Impossible Physics. 2 days ago, something changed on October 1st, 2025. An anonymous post appeared on 4chan, not on a science forum, not on a scientific discussion server, but on 4chan's paranormal board, a place known more for internet folklore than legitimate scientific discourse. But this was no folklore. The poster claimed to be a PhD researcher working with the European Space Agency. They said they had ongoing access to the combined observational data on B.I. Atlas, and that they were part of an official working group trying to understand the object. And that team failed. Quote, "For months I was a part of a formal working group that tried and failed to reconcile the behavior of this object with any known type of natural celestial body. The official position is that BAI Atlas is a uniquely active but still natural comet. This position is no longer tenable, and the silence from leadership on the cognitive dissonance this requires is becoming a serious professional issue for more and more of us." Now let me be clear. Anonymous posts on 4chan are not peer-reviewed science. They are not verified. They could be elaborate fiction, role play, or someone who has read the papers and decided to stir up speculation. But here's what makes it different. The level of technical detail is unusual. The frustration in the tone seems genuine, and the claims align unsettlingly well with the available public data, while adding context that has never appeared in any official communications. So I am going to present what this person said, not as fact, but as a window into what might be happening behind the scenes. When scientists look at uncooperative data, the post begins with outgassing. BAI Atlas is ejecting about 150 kilograms of gas and dust every second. This is not speculation. It is measurable. The James Webb Space Telescope has observed it. The spectrographs at the Very Large Telescope have confirmed it. The object is hemorrhaging material as carbon dioxide, water ice, dust particles in a constant violent stream. And according to this researcher, it's doing nothing. Quote, "It feels like a mistake in the data until you've checked it 100 times with all available instruments. The object is ejecting about 150 kilograms of gas and dust per second. We see that, but it does nothing. It's like watching a howitzer fire a shell with absolutely no recoil, smoke, or report. It is a constant violent event with no consequences, and it's a sickening violation of basic physics. Let me explain why that's a problem. When a comet releases gas, it experiences a thrust. Newton's third law, for every action, has an equal and opposite reaction. The gas jetting from the comet's surface pushes it backward, very slightly, yes, but measurably. Over time, this creates what astronomers call acceleration, non-gravitational, a slight deviation from a purely gravitational orbit. Every active comet shows this. Comet Hale-Bopp by Borisov, the previous interstellar visitor. All of them exhibited non-gravitational acceleration that was measurable as they outgassed near the sun. Atlas showed almost none of that. There was a paper published in September, written by Richard Khalid, Avila, and Peter Veris, where they analyzed 4,022 observations of its position from 227 observatories worldwide, gathered from May to September. They calculated the object's orbit with extreme precision. Then, they looked for deviations, the residuals, any sign that outgassing was pushing the object off course. The upper limit they found was 0.28 arcsecons over months of observation, which corresponds to a non-gravitational acceleration of less than 1.5 meters per day squared, for an object ejecting 150 kilograms per second. That number is impossibly small, almost zero. The only way the physics works, according to the authors, is if this object is much more massive than it looks. Quote, "The only way the physics works is if the object has the mass of a small moon, crammed into a space no more than 2 to 3 kilometers across. The lower models give us a limit of 33 billion tons. This just creates a second, worse problem. Finding a mountain on an interstellar trajectory is statistically impossible. Think about what that means. If Atlas has the mass to resist the recoil from ejecting 150 kilograms per second, it would have to be extremely dense, much denser than ice, denser than rock, approaching the density of iron. A solid iron-nickel sphere 3 kilometers in diameter would have about that mass. But this is not a metallic asteroid. It has a coma. It has a tail. It is outgassing like a comet, so the mass must be there. But it must somehow be compatible with volatile ices on the surface." The author continues, quote, "Our surveys have only just begun. Finding such a massive object this early on means the galaxy is not just sprinkled with debris, it is teeming with them. The models are off by a factor of 10,000. Our entire picture of what gets ejected from solar systems is fundamentally and bizarrely wrong. Or this object is not debris at all, and that is the quiet and terrifying conclusion we are being discouraged from discussing." Let's pause here. Let that sink in. If the mass estimate is correct at 33 billion tons or more, then the statistical models collapse. Because large interstellar objects should be rare, exponentially rarer than small ones. For every mountain-sized boulder, there should be millions of pebbles. Yet, we have detected 3 interstellar objects so far. A small, pancake-shaped object, a relatively normal comet, and now something 1,000 times more massive. The sequence is reversed. Either we've been extremely lucky, or the galaxy contains many more giant interstellar objects than we thought, orders of magnitude more. That would mean our understanding of planetary system formation, of how matter is ejected into interstellar space, is wrong on a fundamental level. Or the third option, this object is not debris. But it gets worse. According to the Post, the chemical composition makes no sense either. Quote, "You look at what's actually in the gas. It's even worse. We're seeing pure atomic nickel evaporating. It's happening at a temperature where it should be frozen solid. And this isn't gradual. Like ice turning to vapor, it's a switch. The nickel production is extremely sensitive to sunlight. A small change in heat and it just shuts off. There's only one way you get that. The decomposition of a parent molecule. The only option is nickel tetracarbonyl, something we use in industrial refining. It explains everything, especially why there is no iron. But it's not a naturally occurring compound. It's a synthetic chemical. What on earth is it doing on a rock we thought has been in space for billions of years? So let's talk about that for a moment. It's a chemical compound. The formula is nickel bonded to 4 carbon monoxide groups at room temperature. It's a colorless liquid, very toxic, very volatile, and it was discovered in 1890 by a chemist named Ludwig Mond, and we use it in industry, in a process called the Mond process to purify the metal nickel. You take impure nickel and expose it to carbon monoxide gas, under specific conditions, and nickel tetracarbonyl forms. Then you heat it in another chamber. The compound decomposes, and you are left with pure nickel. It is a refining technique that was patented. In the year 1890, how does a synthetic industrial chemical end up on an interstellar comet? One option. Perhaps the conditions for the formation of nickel tetracarbonyl exist somewhere in space. Protoplanetary disks are very rich in carbon monoxide. If metallic nickel particles are present, and if the pressure and temperature are right, perhaps the compound would form naturally. Not impossible, but unlikely. And even if it did form, nickel tetracarbonyl is not stable. It decomposes over time, especially when exposed to radiation. An object traveling through interstellar space for billions of years, bathed in cosmic rays, should not have intact nickel tetracarbonyl on its surface, unless it is being actively, continuously produced by some internal process. That was the suggestion made that Atlas was not carrying ancient nickel tetracarbonyl from its formation. It was creating it as a byproduct of whatever was happening inside. Then there was the iron, or rather, an absence not seen in normal comets. Nickel and iron occur together. Both are present in similar ratios. As we see in the Sun, about 1 nickel atom for every 20 iron atoms. That is the cosmic abundance. That is what you would expect from material formed in a protoplanetary disk around a star. Atlas showed an extreme dominance of nickel. Iron only appeared in the spectrum when the object was closer than 2.64 astronomical units. Even then, the ratio of nickel to iron was still much higher than normal, off by an order of magnitude. Why, if both metals were present in the comet's composition, why was nickel sublimating freely while the iron remained locked away? The proposed explanation involved nickel tetracarbonyl. Iron does not form an equivalent volatile compound. Iron pentacarbonyl exists, but it is less stable, less likely to form under the same conditions. If the outgassing process preferentially produces nickel tetracarbonyl, you would see nickel without iron, a chemically selective reaction. But again, that requires an active process, not just ice sublimating and carrying along metallic particles, something chemically complex. Now let's talk about the dust, because the polarization data is where things get really strange. When light scatters off dust particles, it becomes polarized. The degree and angle of polarization depend on the size, shape, and composition of the particles. Astronomers use this as a diagnostic tool. You measure the polarization, compare it to models, and you can infer what kind of dust you're looking at. Every comet and asteroid ever studied falls within a predictable range. Silicate dust, ice grains, carbonaceous particles. They all produce similar polarization signatures. Minor variations, sure, but within limits. BAI Atlas was off the charts according to the public data. The polarization at a 90-degree phase angle was negative 2.1%. Negative polarization at that geometry is rare, very rare. It usually requires extremely irregularly shaped particles or complex internal structures. The leaked post described the reaction when the data first came back. Quote, "Our director insisted we had it wrong for nearly a week, until we replicated the results. They checked the instruments, recalibrated, observed again. The answer was the same. The only way to explain the numbers, according to the post, was if the dust particles were fundamentally different, not natural dust. Not the kind of grains that form when ice sublimates and lifts rocky material off a comet's surface." Quote, "Large, extremely complex particles, black and fluffy like smoke. Think about what that means. Typical cometary dust is small, micron-sized, a few micrometers in diameter, simple grains. But large, complex particles suggest something else. Aggregates, fluffy structures with lots of empty space inside, large surface area, low density, almost like soot or an aerosol. That's the kind of dust you get from combustion, or from chemical vapor deposition, processes that build particles atom by atom, layer by layer, creating intricate structures, not processes that occur naturally on a frozen rock. And the black color, most cometary dust is relatively bright. It reflects a significant amount of sunlight. That is why comets are visible. But black dust absorbs light. It's thermally efficient. It heats up quickly. If the dust around Comet Atlas is black and porous, it would absorb solar energy, heat up and radiate in the infrared, which brings us back to the heat problem. Where does all that absorbed energy go? The Post considers the chemical strangeness as part of a larger pattern, citing wrong chemistry, wrong physics, that it's a completely self-consistent wrong system, as if its entire purpose is to make us doubt ourselves. Self-consistent, that's the key phrase. Each anomaly considered alone could be explained. Unusual, but possible. But together they form a system, a coherent picture, just not one that fits the hypothesis, of a natural comet. It's like looking at a machine, where every part is slightly out of spec, but the machine still runs. You start to wonder if the specifications are wrong, or if the machine was built to different standards. Now I want to be clear. The official scientific position, the one held by most astronomers, is that Comet Atlas is a comet, an unusual comet, yes, with characteristics just outside the bounds of what we've seen before, but still natural, still explainable within the framework of science. NASA has said this explicitly. Tom Stutler, NASA's lead scientist for small bodies in the solar system, told reporters, quote, "It looks like a comet. It does cometary things. It is very, very similar in every way to the comets we know." And he's not wrong. Comet Atlas has a coma. It has a tail. It's outgassing as it approaches the sun. Those are cometary behaviors. But the details, the chemistry, the dust, the thermal balance, that's where the questions lie. The Insider's Post doesn't make a definitive claim. They're not saying this is definitely alien or this is definitely artificial. What they are saying is simpler and in some ways more disturbing. Quote, "For months, I have been part of an official working group that has tried and failed to reconcile this object's behavior with any known class of natural celestial body. Failed. Not that we are still working on it. It's not that we need more data of failure. That's the word they used. And if this leak is real, if it reflects the internal discussions, actually within the working group of the European Space Agency, then there are scientists who are looking at this data and are privately admitting that they don't have an answer. This raises a question. If the standard explanations don't work, then what does? That's where the Post then veers into a territory that sounds like theoretical, physics or science fiction, depending on how generous you're feeling. Chapter 5. Non-existent spin. Every object in space spins. It's unavoidable. Collisions impart spin. Gravitational interactions add angular momentum. Even the gentlest cosmic encounter billions of years ago leaves an object tumbling through the void. Spin is the default state. So, when astronomers observe a new comet or asteroid, one of the first things they look for is the rotation period, how fast it's spinning. They watch the brightness over time as the object turns, as different parts of its surface face the observer. Dark spots, bright spots, irregular shapes. The brightness fluctuates, sometimes subtly, sometimes dramatically, but it fluctuates. This is called a light curve. Plot the brightness over time, and you get a periodic wave. The period tells you the spin rate. The amplitude tells you how irregular the shape is. It's one of the most fundamental measurements. In observational astronomy, the Atlas paper has none. According to the leaked Post, the object was tracked continuously. Hubble observed it. Webb observed it. Ground-based observatories tracked it night after night, and the brightness was constant. Quote, "We stared at it for days on end. Its brightness didn't change by a fraction of a %. It's a flat line, no variation, no flicker, No periodic signal, that is wrong. Not just unusual, but wrong. Even a perfectly spherical object, if it has surface features, any variation in albedo, any patch that is darker or lighter than average will show a change in brightness as it rotates. And comets are never perfectly spherical. They are irregular, rugged, covered in craters, with jets of gas that create bright spots. The buildup of dust creates dark spots, and its rotation should produce a rhythm. But by Atlas did not flicker. Now there is a scenario where you might not see the rotation if the object spins very slowly. If the period lasted for weeks or months, you might not detect a full cycle within the limited observation windows. But even then, you would expect to see a gradual change in brightness as the object slowly turns, a drift, a trend, anything at all. The report described the brightness as unvarying, stable, locked in. So, either BY Atlas is not rotating at all, which is physically implausible, for an object that has been moving through space for billions of years, or it is rotating, but its brightness is somehow independent of its rotation, which requires an explanation. This is where things become more complex. Both Hubble and Webb observed a feature, a forward-facing tail, a plume of material pointing toward the sun. The natural explanation is a jet, a localized outgassing event, on the sun-facing side of the comet, where solar heating is strongest. Jets are common on comets. Sublimating ice creates pressure. Gas escapes through cracks or vents, and the entrained dust forms a directional plume. But jets are by definition asymmetrical. They erupt from one location in one direction. If the object is rotating, the jet will rotate with it, sometimes pointing toward you, sometimes away, and sometimes to the side. The amount of reflected sunlight changes. You would get a pulse, a flicker, a change in brightness tied to the rotation period. By Atlas has a feature that looks like a jet, but there is no change in brightness. Those two observations are incompatible. The report states it bluntly, quote, "A jet strong enough to produce the tail would make the object flicker. It does not. The explanation for the tail requires a directional and intense event, while its light observation requires a completely uniform cloud. You cannot have both. One of the two must be false, or the model for the tail is false, or that cloud is not natural. Let's analyze that. If the tail is real, driven by a jet, that jet would be visible as a periodic change in brightness. But the brightness doesn't change. So either the tail is not a jet, it's something else, or the brightness is somehow decoupled from the jet. One possibility. The outgassing is isotropic, perfectly symmetrical, happening equally in all directions, at all times, like a slowly evaporating sphere. No jets, no asymmetry. That would explain the constant brightness. But it doesn't explain the forward-pointing tail. Isotropic outgassing creates a symmetrical coma, and a tail pushed back by the solar wind, not a forward-pointing plume. Another possibility. The dust cloud surrounding the object is so thick, so optically dense, that it smears out any brightness variations. The jet could be firing, but it's hidden inside a shroud of fog. What we see is the outer shell, which appears uniform. That could work, but it requires a huge dust production rate, and the spectral data suggests the coma is relatively thin, not optically thick. A third possibility. The object is actively regulating its brightness, somehow maintaining a constant reflective surface, regardless of its rotation or jet activity. That sounds absurd, but it's the only scenario that reconciles both observations without dismissing one as an error. The insider suggests that this points to something deeper, that the rotation problem isn't a separate issue. It's part of the same anomalous system, the same underlying machine that produces the non-ballistic outgassing, creates synthetic chemicals, ejects artificial dust, and that machine, according to the Post, is internal, not solar-powered, not driven by external heating. This brings us to the next piece of the puzzle, the thermal ghost. Atlas is absorbing gigawatts of solar energy. This isn't an estimate. It's calculable. You take the object's cross-sectional area, multiply it by the solar flux at its distance, and you get the power input. For an object 5 kilometers in diameter, at about 2 astronomical units from the Sun, the absorbed power is around a few gigawatts, enough to power a small city. That energy has to go somewhere in a typical comet. It goes into sublimating ice, water ice, carbon dioxide ice, and other volatiles. The phase change from solid to gas absorbs energy. A lot of energy. That's how comets stay cool. The sublimation process acts as a heat sink, transferring energy into the outflowing gas. But here's the problem. The amount of energy being absorbed doesn't match the amount of material being released. According to the leaked Post, the thermal models don't balance. Quoting, "We calculate the energy budget, and there's a large surplus. Where must that heat go? It should be driving off huge plumes of water vapor, but the water isn't there." The Webb telescope measured the gas composition as mostly carbon dioxide, some carbon monoxide, and water was present, but in much smaller quantities than expected. The ratio of carbon dioxide to water was 8 to 1. That is extremely high. Most comets are water-dominated. Water is the primary volatile. It's what drives cometary activity. But if BAI Atlas is absorbing gigawatts and not releasing a corresponding amount of water, then where is the energy going? One option: it's being radiated away. Objects emit thermal radiation. The hotter they are, the more they radiate. If Atlas has a high emissivity, if its surface is efficient at radiating heat, it could shed energy into space without having to sublimate large amounts of ice. But there's a problem. The spectral data shows a cold surface temperature, very cold. Much colder than it should be for an object absorbing that much sunlight. Quoting from the Post, "The thing is frigid. It's like pointing a blowtorch at an ice cube and watching it refuse to melt. So the object is absorbing gigawatts, not releasing water, and staying cold. Where's that energy disappearing to? Where's it going?" The Post suggests the object has found a way to regulate its thermal load. Quoting, "The object has figured out a way to either shed or regulate a massive thermal load, to keep its surface locked at a specific low temperature. Regulation. That word again implies control, implies a system, not passive thermal physics but active management. If the surface temperature is being kept artificially low, that requires either a very efficient cooling mechanism or an internal heat sink, something that absorbs energy and stores it, or transforms it without raising the surface temperature. What could do that naturally? Not much. Definitely not on a comet," was the insider's conclusion. Quote, "The gigawatts from the Sun are a negligible external variable for a monstrous 3-billion-year-old object, with its own energy source. It passively radiates the solar energy away, like any other inert rock, because the Sun is not a part of its life cycle, its own power source. An internal engine, something that generates energy from within, is independent of solar heating. And if that is true, then its thermal regulation is not a mystery. It is a consequence. The object does not need the Sun. It is indifferent to it. This raises the most disturbing question of all: if 3Y Atlas has an internal power source, what is it?" Chapter 6. The Carbon Hypothesis. The leaked Post takes a turn here, into a realm of physics that sounds like science fiction. But according to the researcher, it is the only framework that makes the data coherent. Quote, "It is a macroscopic quantum object, a stable, massive particle left over from the first microseconds of the Big Bang, a bubble of a different set of physical laws that managed to survive. hidden in a shell of our reality. The name for this engine in theoretical physics is a non-topological soliton. This is not a theory. It is the only known physics that makes the data coherent. A cue ball. Let us talk about what that means. In the early universe, just after the Big Bang, conditions were extreme. Temperatures and densities were far beyond anything we can replicate at those energies. The fundamental forces behaved differently. The distinct particles of today, electrons, quarks, photons, were unified in a hot plasma. As the universe expanded and cooled, it underwent phase transitions. Symmetries were broken, forces separated, and matter condensed into the forms we recognize. But these phase transitions did not always happen uniformly. Just as water freezing into ice can create pockets and bubbles, the early universe could have created defects, regions where the transition did not complete cleanly, pockets where the old unified state persisted, trapped, and stable. These defects have names: cosmic strings, monopoles, domain walls, and cue balls. A cue ball is a non-topological soliton, which is the technical term for it. A soliton is a self-sustaining wave, a packet of energy that holds its shape, thanks to a balance between the dispersive forces trying to make it spread out and the non-linear effects that pull it back together. Non-topological means it is not held together by the geometry of space like a knot. It is held together by a conserved quantity, a charge. The Q stands for Q charge. In certain theoretical models, especially the supersymmetric extensions of the Standard Model, cue balls can form. They are made of scalar fields, fields with zero spin, and these fields have potential energy and, in the right configuration, they can create a stable, massive object, a bubble where the field inside has a different value than the outside. The bubble does not collapse because the field configuration is energetically favorable. It is a local minimum in the potential energy landscape. The key characteristic is that a cue ball is its own power source. The field inside is decaying very slowly, releasing energy over billions of years. That energy manifests as particles of thermal radiation. The cue ball gradually loses mass. But this process is so slow that a cue ball formed in the early universe could still exist today. Now, this is speculative physics. Cue balls have never been observed. They are predicted by certain theories, but those theories have not been confirmed. Most physicists consider them interesting hypotheticals, objects that could exist in the universe, but probably do not, except that insiders are claiming the Atlas object fits that profile perfectly. Let us consider the logic. If the Atlas object is a cue ball, what would we expect to see? First, enormous mass in a small volume. Cue balls are very dense. The internal field is concentrated. A cue ball, 3 kilometers in diameter, could easily have the mass of a small moon, 33 billion tons. That matches the estimated minimum mass inferred from the lack of non-gravitational acceleration. Second, isotropic outgassing. The cue ball's decay is happening internally at the core. The energy is released uniformly in all directions. It heats the surrounding material, a mantle of ice and dust accumulated from the inside out. That ice layer sublimates symmetrically. Without a jet, there is no directional thrust. The outgassing is perfectly balanced. There is no jet reaction, which explains the howitzer with no recoil. The violent outgassing has no consequence. The internal decay engine generates the gas. The gas escapes equally in all directions. Newton's third law is satisfied. Action and reaction cancel each other out. Third, the constant brightness. If the outgassing is isotropic, the cloud of dust and gas surrounding the cue ball is spherically symmetric. The rotation is irrelevant. The object looks the same from every angle. The brightness doesn't flicker because there is no asymmetry to rotate. Fourth, the strange chemistry. The decay of the cue ball does not follow conventional thermodynamics. It is a high-energy particle physics process, capable of creating unusual compounds. The slow-burn reactor, as the Post calls it, operates at a constant low temperature, but it is not a thermal furnace. It is a quantum decay event over billions of years. This creates byproducts, complex molecules, metal carbonyls, artificial dust, the exhaust of an ancient engine. Fifth, the thermal indifference. The cue ball does not care about the sun. Its internal energy source dwarfs the heating from the sun. The surface temperature is regulated not by absorbing and re-radiating sunlight, but by the steady output from its core. The gigawatts from the sun, quote, are a negligible external variable. Sixth, the orbit. If cue balls are common, if they are a component of dark matter, then the galaxy is filled with them. Not rare, not unusual, but everywhere. It is not a fragment ejected from a distant star. It is part of the fundamental population, a relic from the Big Bang. That explains why we found something so massive and so fast. We are not looking at ejected planetary material. We are looking at dark matter itself. The Post considers this a revelation. Quote, the cue ball is the mass. Its engine is its own decay. The lack of recoil is no longer a paradox. It is a defining feature. The outgassing is not a jet. It is an isotropic ablation, a perfectly spherically symmetric flow of matter. As the core's energy boils, its mantle from the inside out, with no net thrust. It moves without consequence, because the event is happening inside a perfectly balanced system. And then, quote, this is not a matter of belief. This is the only known physics that makes the data coherent. Once you look at it, the entire flawed system clicks together into a logical picture. Horrifying. Horrifying, that is the word used. Not fascinating, and not surprising. Horrifying. Why? Because if BY Atlas is a cue bow, then dark matter is not something invisible, just scattered throughout space. It is active, it is heavy, and it is everywhere. The galaxy is not sprinkled with a few interstellar rocks. It is teeming with massive ancient objects, each one a relic from the Big Bang, each one slowly decaying, each one capable of wandering into a solar system and doing what exactly nothing at all, or something much worse. But here is the important part. The cue bow hypothesis is testable. The Post ends with predictions, specific claims that can be falsified. Quote, screenshot this. Prediction 1. Activity independent of solar distance. The behavior of a normal comet is driven by solar heating. As it moves away from the sun, activity drops. Outgassing slows. Brightness fades. This is common. Every comet we have observed follows this pattern. But if BY Atlas has an internal engine, its activity will not follow that pattern as it recedes into the outer solar system, past 3 astronomical units, past 4 magnitudes, and its rate of mass loss will remain unbelievably high. It will violate thermodynamic expectations. For a passively cooling body, that is testable. We can observe when the object reemerges in December. After passing behind the sun, we will have months to watch it. As it moves outward, if it stays bright, if the outgassing continues unabated, that is irrefutable proof. Comets do not do that. Prediction 2. High-energy emissions. The decay of carbon is a particle physics event. 73 megawatts of energy according to the Post's estimate. That energy does not just disappear. It produces particles, high-energy particles, gamma rays, X-rays, a sign of non-thermal high energy. That should be detectable. Quote, point a gamma-ray telescope at it. If you detect a signal that cannot be attributed to solar-wind interaction, you are not seeing a comet. You are hearing the pulse of an object that does not follow the laws of physics. That is also verifiable. Gamma-ray observatories exist. Fermi, integral. If there is a high-energy source at the location of BAE Atlas, we can find it. No comet emits gamma rays from intrinsic processes. Only extreme astrophysical objects do that. Pulsars, magnetars, supernova remnants, or if the hypothesis is correct, QUBOs. Now, let me be absolutely clear. This is not mainstream science. QUBOs are a speculative theory. Most astrophysicists would dismiss this hypothesis immediately. It is too strange. It requires accepting that dark matter has a form we have never detected, that the early universe created macroscopic quantum objects that are stable, and that one of those objects happens to be passing through our solar system right now. The simpler explanation is that BAI Atlas is just a strange comet. Unusual chemistry, unusual dust, perhaps a binary nucleus or some internal structure we do not fully understand, but still natural, still explainable within the framework of normal planetary science. That is the view most scientists hold, and they are probably right. But if the leaked post is real, if there really is a European Space Agency task force struggling to make the data fit, then the QUBO hypothesis is being quietly discussed behind closed doors, not as the answer but as the only alternative. That does not require ignoring half the observations. And if the predictions hold up, if BAI Atlas remains bright as it departs, if gamma rays are detected, then the conversation will change quickly. Chapter 7. The Hidden Maneuver Window. 26 days to go. BAE Atlas is about to do something that should have people worried. It is going to disappear. Not literally. The object will still be there, still moving on its trajectory. But from Earth's perspective, it will be invisible, hidden behind the sun, swallowed by the glare of our own star. This happened on October 24th, when the object reached conjunction with the sun. Earth, the sun, and 3A Atlas formed a straight line with the sun in the middle. From that point until early December, we were unable to see it. It was impossible to track it, to measure its position, brightness, or spectrum. For nearly 6 weeks, the object disappeared from view, and on October 29th, right in the middle of that period of invisibility, 3A Atlas reached perihelion, its closest point of approach to the sun, at about 1.4 astronomical units, just inside the orbit of Mars, the point at which solar heating would be most intense, when a normal comet would be most active, when outgassing would reach its peak. We would see none of it. This timing did not go unnoticed. Avloof wrote about it explicitly in his October 3rd paper. Quote, "At perihelion on October 29th, 2025, when it reaches 1.35 astronomical units from the sun, 3A Atlas will be completely obscured from Earth by the sun. If we assume this occultation occurs within a solar elongation of 30 degrees, then the calculated probability of this alignment with the sun and Earth is about 7%. 7% is not impossible, but neither is it a 1 in 14 random chance. And this is where things get uncomfortable. If 3A Atlas were a spacecraft, if it had propulsion, if it could maneuver, perihelion would be the optimal time to do so, specifically to perform what is known as a reverse Oberth maneuver. Let me explain. The Oberth effect is a principle in orbital mechanics. When you fire a rocket engine, the change in kinetic energy depends not just on the thrust, but also on your current velocity. Fire the engine when you're moving fast, and you will get more efficiency for your effort. The increase in kinetic energy will be greater. Spacecraft use this all the time. When you want to escape a planet or a star, you apply thrust at periapsis, the point of closest approach, where your orbital velocity is highest. That's a standard Oberth maneuver, maximum efficiency. A reverse Oberth maneuver is the opposite. You're moving fast on a hyperbolic trajectory, heading out of the system. But you want to stay. You want to become gravitationally bound. So you fire your engines at perihelion, when you're moving fastest, and you slow down. Reducing velocity is most effective at that point, as you remove energy, and the orbit changes from Hyperion to elite instead of escaping. You are captured. If, by Atlas, wanted to remain in the solar system, October 29th would be the time to apply the brakes, and it would happen behind the sun, obscured from Earth, unobservable. Loeb expressed this carefully. He did not claim this would happen. He pointed out that the geometry was very convenient, quoting from his paper. This may have been intentional to avoid detailed observations from Earth-based telescopes when the object was at its brightest, or when devices were sent to Earth from that obscured vantage point. The optimal point for a reverse Oberth maneuver to become bound to the sun is at perihelion. This very optimal breaking point for Atlas was again obscured from our view by the sun. Devices, that is the word he used. Small probes released from the main object, taking advantage of the retrograde orbit, and close encounters with planets to reach Mars, Venus, or Jupiter with minimal fuel requirements. The calculations exist in a July paper by Loeb, along with Adam Hibbert and Adam Crow. They calculated the delta-5 requirements. Delta-5 is the change in velocity needed to reach a target for by Atlas to send a probe to Mars in early October. The required delta-5 was less than 5 kilometers per second. That figure is comparable to an intercontinental ballistic missile, achievable with chemical propulsion. Venus. A similar story. Less than 5 kilometers per second until July. Jupiter less than 5 until November. Earth required more, always over 5 kilometers per second. A higher energy cost. This, if you were designing a reconnaissance mission, could explain why Earth was bypassed. On the first pass, visit the other planets first, gather data, then decide if Earth was worth the fuel. Again, this is hypothetical. Loeb is not saying this is happening. He is saying that it could happen, that the orbit and timing allow for it. But here's the key point. We will not know until December, when, by Atlas, re-emerges from behind the sun in early December. It will appear in the sky before dawn, low on the eastern horizon, faint but observable, and the first thing astronomers will do is measure its position, calculate its orbit, to check if anything has changed, if the orbit is exactly as predicted, if the object is precisely where it should be based on a purely gravitational path, then nothing has happened. It has passed perihelion, outgassed, and continued on its way, an unusual but natural comet. If the orbit has changed, if there is even a slight deviation, then something happened behind the sun. Either the object maneuvered, or it broke apart, or it experienced another event that altered its trajectory, and that would be very significant. Loeb has identified a specific window for detection, from November 21st to December 5th, quoting from a previous blog post. The authors emphasize that their theory could be disproven if Bialis passes through the solar system without making any unexpected maneuvers, especially during the period from November 21st to December 5th, 2025. The hypothesis would likely be falsified. Those 2 weeks are the critical observation window. If maneuvers occur at perihelion, they would be detectable as orbital deviations. In late November, astronomers will be watching. But there is another layer to this. The theory of a precursor probe in September. Loeb published another calculation. If Bialis had released a smaller object, a probe, at some point in the past, and if that probe was traveling ahead of the main object by about 30 million kilometers, it could have intercepted Mars this week, on October 3rd, the same day as the Mars flyby. The math works out. A probe wouldn't need to be large, a few meters in diameter, maybe 10, the size of a car. At that scale, reflecting sunlight at the distance of Mars, it would be invisible to Earth-based telescopes. We couldn't detect it, but it could be there. The high-rise camera on the Mars Reconnaissance Orbiter shouldn't just look for the main object. As Loeb suggests, it should also scan the approach corridor, searching for smaller objects, the precursors. Is NASA doing this? We don't know. The imaging plans have not been made public at that level of detail, but the possibility exists. And if something shows up in the data, something small and unexpected, the conversation will change immediately. Now, the more likely scenario, the one that most scientists expect, is that nothing happens. Atlas passes perihelion, continues on its way out, fading from view, as just a strange, interesting comet, worthy of study, but ultimately just another interstellar visitor. No maneuvers, no probes, no deviations. That's the baseline expectation, and it's probably correct, but the geometry is uncomfortable. The timing is uncomfortable. The fact that the most critical moment happens when we can't see it, that's uncomfortable. And if you add the Keough hypothesis to the mix, it's even worse, because a Keough doesn't need propulsion. It doesn't maneuver. It's inert. But it also weighs 33 billion tons if it passes close to a planet. It will have a gravitational influence. A planet's orbit might shift a little, but measurably so over time. Mars is the concern. Atlas passes within about 29 million kilometers, which, by today's standards, is close. Not close enough to risk a collision, but close enough for gravitational interactions to be significant. If the object is really as massive as the estimates suggest, Mars would feel a small tug. Its orbital elements, the precise parameters that define its path around the Sun, could change by a detectable amount. Astronomers track Mars constantly. Its position is known with incredible precision. If Atlas causes even a slight gravitational perturbation, we will see it. Not immediately, but over weeks and months. As Mars continues on its orbit, the deviation would accumulate. It's another test, another way to confirm or refute the mass estimates, and the results will come in over the next few months. So we wait. October passes, the object is hidden. November arrives, and observations resume. And by December, we will know if it maneuvered, if the orbit has changed, if the mass is real. The answers are coming, whether we are ready for them or not. Chapter 8. The Decoy Scenario. There is a theory within the theory, a speculation within the speculation, and it could be the most unsettling thought of all. What if A3 Atlas is a diversion? This idea comes from Ofer Dahari, a collaborator of Avi Loeb. He suggested that an advanced civilization might use an interstellar comet, a natural-looking one as a decoy, something bright, something obvious, something to attract telescopes and attention while the real activity takes place elsewhere. Loeb discussed this in an August blog post, quoting my collaborator. Ofer Dahari suggested that aliens might use an interstellar comet, a natural one, as a decoy to draw our attention, while they conduct another activity at a different location near Earth. With that in mind, it would be interesting to check if there is an increase in the activity of unidentified anomalous phenomena in Earth's atmosphere. After A3 Atlas makes its closest approach to the Sun on October 31st, 2025. If UAP activity increases around the time A3 Atlas reaches perihelion, that would be testable, and someone is testing it. The Galileo Project, Loeb's initiative, an astronomical research program designed to search for evidence of extraterrestrial technology, not through radio signals, not through distant exoplanets, but here near Earth, using telescopes and sensors to monitor the sky, searching for anomalous objects. The project has 3 observatories, one at the Harvard College Observatory in Massachusetts, one in Pennsylvania, and one in Nevada. Each station is equipped with cameras, infrared sensors, radar, and audio detectors. They scan the entire sky continuously, recording everything that moves overhead. The system uses artificial intelligence to classify objects like birds, planes, satellites, drones, and meteors. Most things are normal, easily explained. But occasionally something shows up that doesn't fit. An object moving too fast or too slow, or changing direction in ways that conventional aircraft cannot. Those are flagged, analyzed, and investigated. The Galileo project has been operational since late 2022. It has collected data on 500,000 aerial objects. The vast majority have been identified and explained, with nothing unusual found. But the system is still there observing, and according to Loeb, it will be observing closely during October and November. Quote, very exciting. The Galileo project will be monitoring the skies under my leadership with 3 observatories in Massachusetts, Pennsylvania, and Nevada during that period. So, if UAP activity increases, if something strange starts appearing in Earth's atmosphere, while Atlas is behind the sun, the Galileo project will catch it, and if there is a correlation, if the timing matches, that would be very interesting. Now let's be clear about what this means. Loeb is not predicting that ships, alien spacecraft, will appear. He is not saying Atlas is definitely a decoy. He is saying that if it were, we should look for secondary activity, and his team is positioned to do just that. The decoy hypothesis rests on a few assumptions. First, that Atlas is either artificial or controlled. Second, that its purpose is not direct contact, but reconnaissance. Third, that whoever sent it or whoever is using it wants humanity distracted, focused on the big, obvious object while smaller. Stealthier activities take place closer to home. Why would an advanced civilization do that? One reason: information asymmetry. If you are spying on a potentially hostile or unpredictable species, you don't introduce yourself. You gather data quietly, you deploy small, low observable probes, and you make sure the target's attention is elsewhere. Atlas is loud, unusually bright. Every major telescope on Earth and in orbit has looked at it. Papers are being written. Scientists are debating. The media is covering it as a spectacle. And while everyone is looking up at the comet, what is happening down here? In the atmosphere, in orbit? Are there small objects, silent objects, doing things we are not noticing? The Galileo project's data will tell us, or at least it will tell us if there is an increase, a statistical anomaly, more unexplained objects than usual, clustered around late October, early November, if that happens. It doesn't prove the decoy hypothesis. Correlation is not causation, but it would be hard to ignore. There is another angle to this, the theory of a stealth hybrid spacecraft proposed by Gabor, a reader of Webb's works. The idea is, an advanced civilization might not build spacecraft from scratch. They could use natural materials, asteroids, comets, repurpose them, hollow them out, install machinery inside, using the natural outer shell as camouflage. Webb quoted Seuss on his blog, quoting, "Humanity has already planned asteroid mining missions, and for a more advanced civilization, this could be a simple method. An asteroid shell provides excellent natural shielding. The object offers inherent stealth. As long as there are no active emissions or artificial reflective surfaces, externally it looks like a natural asteroid. This solves a problem. If you want to send something to another star system, you need shielding from cosmic rays, high-energy particles, micrometeoroids. Interstellar space is harsh. Building thick walls is very expensive and heavy. But if you start with a rock, the shielding is already built in. You just need to excavate the inside. Install your systems and be on your way. From the outside, it looks like a comet. It has a coma. It behaves normally. But inside there is machinery, equipment, a power source, maybe even crew in hibernation, waiting. This is not a new speculation. Science fiction has used this idea for many decades. Arthur C. Clarke's Rendezvous with Rama, a giant cylindrical spacecraft disguised as an asteroid. Greg Bear's Forge of God, self-replicating machines hidden inside comets. The concept is familiar, but it is also practical. If you are crossing interstellar distances, if you are spending millennia in transit, it makes sense to use natural materials, and it makes detection more difficult, because astronomers assume that rocks are rocks. Unless they do something obviously artificial, they will be classified as natural. Oumuamua hasn't done anything obviously artificial. No radio signals, no course corrections, no artificial lights. It just doesn't quite fit the chemical data. Physical anomalies, a suspicious trajectory deviation. But none of that is proof. That is the brilliance of a stealth hybrid design. It is deniable, ambiguous. You cannot prove it is artificial without getting close. Very close. And by the time you could launch a mission to intercept it, it would be long gone. So we are left with questions. Is Project Galileo about to see anything unusual? In the coming weeks, will reports of UAPs increase? Will there be objects that do not fit? And if so, will anyone connect them to BY Atlas? Or will October and November pass by quietly, with no anomalies, no increase? Just a comet passing behind the sun and re-emerging on the other side. Strange, yes, but ultimately natural. The data will answer one way or another. We just have to wait a few more weeks. Chapter 9. The Silence Protocol. The scientific community is divided over this object, not publicly, not in press conferences or official statements, but in quieter spaces, email chains, conference hallway chats, late-night lab discussions. There are two camps, and the gap between them is widening. One side says BY Atlas is an unusual comet, yes, pushing the boundaries, but still within the realm of natural phenomena. The trajectory can be explained by strange parent molecules we have not yet identified. The mass estimates could be wrong. Better data will clarify. Patience and rigorous science will resolve the anomalies. The other side is less certain. They see the same data. They run the same calculations. And they are getting answers that do not fit. Not just at the edges, but at the core. The physics does not work unless you accept seemingly impossible premises. Immense density, an internal power source, synthetic chemistry. The leaked 4-page post says about this division, citing the official position that BY Atlas is a comet that is uniquely active but still natural. This position is no longer tenable, and the silence from leadership about the cognitive dissonance that this requires is becoming a serious professional issue. For more and more of us, that cognitive dissonance is a powerful phrase. It means holding two contradictory beliefs simultaneously. In this case, believing that the data is correct, while also believing the object is natural. Because if the data is right, natural does not fit. And if natural is right, the data had to be wrong. But the data was checked multiple times, by multiple independent teams using different instruments, different methods, and it kept returning the same result. So, where does that leave researchers? Unable to reconcile it. According to the Post, they are being discouraged from discussing alternatives. Not forbidden, not censored, just discouraged. Professional incentives push towards conventional explanations. Papers proposing exotic hypotheses receive harsher reviews. Grant proposals that mention terms like artificial or non-natural face skepticism. Careers can stall. And this isn't unique to BY Atlas. It's a broader issue in science. The pressure to stay within accepted frameworks, to not rock the boat, to be conservative in one's claims most of the time. This is healthy. It prevents wild speculation from overshadowing solid work, but occasionally it creates blind spots, places where the data is pointing one way and the community is looking another. Jason Wright, an astronomer at Penn State, has been vocal about this. He has been critical of Avi Loeb's approach to bi-Atlas and, before that, Oumuamua. He argues that Loeb is too quick to invoke artificial explanations, that he dismisses basic observations, that his claims grab media attention, but don't hold up under scrutiny. Wright wrote in a blog post, quote, "Avi has made a name for himself by suggesting and outright claiming that objects could be alien spacecraft, even when there is little or no objective reason to think so." Soon after, Avi was claiming bi-Atlas was an alien spacecraft. He goes on to criticize specific claims. The idea that the extended light source, observed by telescopes, was just image blurring. Wright points out that modern telescopes compensate for an object's motion. They track them, stacking images. Blurring isn't an issue for professional observatories. If multiple independent observations show an extended light source, it is real. Bi-Atlas has a coma. That would make it a comet, but Loeb's response was more nuanced than Wright's criticism suggested. Loeb was not claiming certainty. He was proposing a scale, a framework where the Loeb scale goes up to 10, in which 0 is certainly natural, and 10 is certainly artificial. He rated bi-Atlas at a 6, not a certainty, not proven, but high enough to warrant a serious investigation. The scale itself is interesting. It is designed to move the conversation away from binary thinking, not whether it is alien or not, but how anomalous it is, how much it deviates from expectations, and what level of anomaly triggers what kind of response. Loeb has proposed that this scale should be formally adopted by an international body, specifically the United Nations. In November, a white paper was submitted, authored by Ofer Dahari, Gershon, Terracina, Tenenbaum, and Avi Loeb, titled Advancing Interstellar Science, a global framework for the comprehensive study of interstellar objects. It proposes the establishment of UNISO, the United Nations Committee for Interstellar Objects. The idea is simple. As detection capabilities improve, especially with the Vera Rubin Observatory coming online, we will find more interstellar objects, many more. Estimates suggest one object every few months, possibly more. Each one is a fleeting opportunity. They pass by quickly. If we want to study them, we need rapid international coordination, planned in advance. UNISO would standardize the response, establish protocols, and create a network of observatories with guaranteed observation time, and maintain a fleet of rapid response spacecraft, ready to launch on short notice, and importantly, implement the Loeb scale as the official classification system. Objects rated 4 or higher would trigger enhanced observation. A level 6 would require notification of the United Nations Security Council. 8 or higher would trigger emergency protocols. Bi-Atlas is currently at a 6. If it maneuvers, if gamma rays are detected, if activity continues independent of solar distance, the rating would increase and the international response would escalate accordingly. The proposal is ambitious. It requires funding, political will, cooperation between space agencies. None of that is guaranteed, but the framework is in place, and Representative Anna Paulina Luna, a Congresswoman, has endorsed it. Her letter of support is cited in the white paper. Whether UNIO becomes a reality depends on how the next few months unfold. If YALAS quietly fades into the void, the urgency will diminish. It becomes an interesting case study, a strange comet worth writing a paper about, but not a crisis. If something changes, if the object behaves in inexplicable ways, the conversation will change, and suddenly, international coordination no longer sounds like excessive bureaucracy. It sounds like a necessity. The other factor at play is transparency, or the lack thereof. The 4-page post hints at internal conversations not made public, unpublished data, unexpressed frustrations. If that is true, If there is a gap between what scientists are saying privately and what is being stated officially, that gap will eventually close, either through leaks or through official disclosure. The scientific method is based on openness. Data should be shared. Hypotheses should be tested openly. Peer review should be transparent. When that breaks down, when information is siloed or controlled, trust erodes and speculation fills the void. Right now, we are in a strange middle ground, with enough public data to ask questions, but not enough to answer them definitively. Key observations: images from the Mars flyby, gamma-ray searches, the orbital measurements from December. Those are still pending, and in that vacuum, people are watching, waiting, some with telescopes, some with theories, and a few, presumably, with knowledge they are not supposed to share. The next chapter of this story will not be written by speculation. It will be written by data, by observations, by measurements, either confirming the conventional explanation or forcing us to consider the alternatives. We are close. The flyby of Mars occurred today. The perihelion window is 3 weeks away. The arrival is in December, 2 months until the end of the year. We will know more, maybe not everything, but more. And if the anomalies persist, if the data continues to refuse to cooperate, then the protocol of silence, in whatever form it takes, will not hold. Because eventually the walls we build around uncomfortable questions begin to crack, and the shape of the room becomes clear, whether we are ready to see it or not. Chapter 10. What happens next? The images from Mars will arrive within a few days, maybe a week. The Mars Reconnaissance Orbiter has transmitted its data to Earth. Engineers are processing it, calibrating, enhancing. Soon we will see what high-rise captured during the flyby. If the comet's nucleus is clearly visible, if it has a diameter of 5 kilometers or more, the debate over its mass will intensify. 33 billion tons becomes harder to refute. The statistical anomaly of finding something so massive becomes unavoidable. Either interstellar space is far more crowded than we thought, or this object is special in ways we do not understand. If the nucleus is smaller, under 1 kilometer, the mystery shifts. Because for a small nucleus to produce so much outgassing, to remain so bright at this distance, is a different kind of problem. It suggests extraordinary activity, internal heat, something driving emissions beyond the simple heating of the sun. Both outcomes raise questions. Neither resolves them. Spectral data from the Mars Express and the ExoMars trace gas orbiter will add another layer. They are measuring the gas composition from a different angle, closer, with instruments designed for atmospheric analysis. If they detect compounds invisible to Earth-based telescopes, if the chemistry looks even stranger up close, that means something. Then there is the brightness monitoring as BAI Atlas moves away from Mars. Continuing toward perihelion, observers on Earth have a narrowing window. By mid-October, the object disappears into the sun's glare. Until then, every night of photometry counts, every spectrum, every polarimetry measurement. Teams around the world are collecting data, storing it, building a timeline. When the object reappears in December, that timeline will become crucial. We will compare its pre-perihelion behavior with its post-perihelion behavior. Does the activity curve match predictions, or does it deviate? A normal comet follows a power law. Its brightness and outgassing increase with the inverse square of its solar distance, or steeper. Activity increases as it approaches the sun, and decreases as it moves away. It's generally predictable. If Bay Atlas doesn't follow that curve, if its activity remains high as it moves past 3 astronomical units, past 4, that's a red flag. Supporting the Cuban prediction mentioned earlier, this would depend on an internal power source, one that is indifferent to solar distance, one that is constant, that is falsifiable, it's testable. We will know by January or February. The search for gamma rays is another thread. Observatories like Fermi and Integral scan the sky continuously. They detect high-energy photons. If Bay Atlas has an internal particle physics process, a decay mechanism creating high-energy particles, those instruments would see it. So far, there have been no public reports of gamma-ray emissions from Bay Atlas. That doesn't mean searches aren't happening. Data takes time to analyze for faint signals. The background noise is high. A detection might not be announced immediately, or it could be sitting in a data set waiting for someone to notice. If gamma rays are detected, and if they correlate with the comet's position, and if they can't be explained by solar-wind interactions, or cosmic ray impacts, that's a game changer. No natural comet emits gamma rays from internal processes. Only astrophysical engines do that. Pulsars, dying stars, supernovae, or potentially exotic matter. The Martian orbital perturbations are a slower signal. Mars is tracked with extremely high precision. Its orbit is known down to the meter. If Bay Atlas exerted a gravitational tug during its close pass, Mars would drift slightly from its predicted path, not by much, millimeters per day. But over months, that adds up. By early 2026, the deviation, if real, will be measurable, and if it matches the kind expected from an object, 33 billion tons. That is an independent confirmation of its mass without needing chemical outgassing. It only requires gravity. The monitoring of UAPs through the Galileo Project's observatories is happening right now. Data is being collected. If there is a spike in unexplained aerial phenomena, coinciding with the perihelion passage, we will see it in the statistics. More objects. Anomalous trajectories concentrated in time. The absence of a spike does not disprove the Lure hypothesis. It only removes a line of supporting evidence. But the presence of a spike would be difficult to ignore, especially if the anomalies cluster in late October, early November, and then taper off. And then there is December, the end of the detection window, designated by Webb for orbital changes if by Atlas maneuvered at perihelion. If it performed a retrograde burn to become bound to the solar system, the deviation would be detectable by then. Observatories would measure the object's position and calculate its trajectory against predictions. If the trajectory is unchanged purely by gravity, then no maneuver occurred. The object passed perihelion naturally. It is leaving. Whatever it is not staying. If the trajectory has changed, if there is a deviation not explainable by outgassing or fragmentation, then something happened behind the sun, something we could not see, and that demands an explanation. The Vera Rubin Observatory adds a final twist. It has begun operations this year. All sky surveys, deep imaging, automated detection. It is designed to find transient objects, things that move asteroids, comets, and interstellar visitors. Models predict Rubin will detect an interstellar object every few months, perhaps more. Within a year or two, we will have dozens. Each one a data point, a comparison. Is, by Atlas, unique, or is it part of a population? The future interstellar objects show similar anomalies. Extreme mass, unusual chemistry, constant brightness. Then, by Atlas is not an exception. It is a preview, a first glimpse of something common in the galaxy that we are only just beginning to notice. If future objects are all normal, small, and well-behaved comets, then Atlas stands alone as an exception. This makes it more mysterious, not less. The bigger picture is this. We are at an inflection point. For the first time, we have the tools to study interstellar visitors in detail, not just to detect them, but to study them. Spectroscopy, high-resolution imaging, rapid response missions, international coordination. Atlas is a stress test. It is pushing every instrument, every model, every assumption, and in doing so, it is revealing the gaps, the places where our understanding is thinner. We think some of those gaps will close. Better data, refined theories, natural explanations we have not yet considered. Science has a way of resolving anomalies, not always quickly, but eventually. Other gaps may not close. They may widen into chasms, and at that point, the conversation fundamentally changes. From what kind of comet is this? To what is this? We are not there yet, but we are close enough to see the edge. The next 3 months will be telling. Mars imaging, the perihelion passage, the gamma-ray searches, the reemergence in December, orbital measurements, UAP data. Each piece adds to the puzzle or complicates it further. And by the time we reach March, when Atlas passes Jupiter and the Juno spacecraft gets its look, we will have a much clearer picture, not complete, but clearer. And if by then the object is still defiant, the explanation is still at a 6 or higher on the left scale, the protocol of silence will be broken. The questions become too big, the data too persistent, and we will have to confront what Giorgio on page 4 said. This is not a failure of our models. It is a glimpse of something underneath them, something we did not know was there. Whether that something is exotic astrophysics, dark matter, ancient relics, or something else entirely, we are about to find out. The universe is patient. It is not in a hurry, but it does not hide. If Atlas has a secret, if there is machinery beneath the surface, it will show itself in the data, through observations, through the slow accumulation of evidence or confirmation, or refutation. We simply have to observe and wait, and be willing to follow where the data leads, even if it leads somewhere uncomfortable, because that is science, not a collection of answers, but a method for asking better questions. And Bay Atlas is asking the best question. We have heard in a long time, what are you? So here we are at the end of an unfinished story. October 3rd, 2025. The Mars flyby happened a few hours ago. The data is streaming back, and somewhere in that data might be an answer, or at least the beginning of one. Take a breath and think about what we have covered. Bay Atlas, an interstellar visitor, the third one we have ever confirmed, but unlike the previous two, this one refuses to behave. It is outgassing 150 kilograms per second with no recoil. It has the mass of a small moon, compressed into a space no larger than Manhattan. It is outgassing nickel at a temperature where nickel should be frozen solid. Nickel, tetracarbonyl, a synthetic industrial chemical, appears in its spectra. The dust it sheds has such extreme polarization properties that scientists thought their instruments were broken. It does not spin, or if it does, the brightness never changes. It absorbs gigawatts of solar energy and stays cold, and its orbit, its timing, its alignment with the planets, are all at probability levels that make statisticians uncomfortable. 7 anomalies, 4 explainable, 3 that will not go away, no matter how much data we gather. And then there was the leak, the anonymous post from someone claiming to work for the European Space Agency, European, describing a working group that tried and failed to reconcile this object with any known natural body, describing chemistry that should not exist on a billion-year-old rock, dust that looked manufactured, an unbalanced heat budget, and one conclusion that was discouraged from discussion, that perhaps, just perhaps, this was not at all the hypothetical Q-Bon fragment, a macroscopic quantum object from the Big Bang, a bubble of a different kind of physics encased in ice and dust, slowly decaying over billions of years, an internal engine that needs no sun, generating strange chemistry as an exhaust, a violent, symmetrical outgassing with no jet propulsion. It sounds like science fiction, but according to the leaks, It's the only framework that makes all the data fit, the only physics that turns a flawed system into something coherent, and it's testable. Two simple predictions can be disproven by observing the object as it leaves the solar system. If activity remains high, independent of distance, that's the first sign. Point a gamma-ray telescope at it. If there's a non-thermal to high-energy signature, that's the second sign. Both predictions will be tested in the coming months. Then there's another 26-day hidden window, when the object disappears behind the sun. Perihelion occurs on October 29th, the perfect time for a maneuver. If a maneuver is possible, it is the perfect time to release probes. If probes exist, and we will not see any of it, no, not until December when the object reemerges, and we check the trajectory. Has it changed? Did something happen? You see, the decoy theory adds another layer. Perhaps the comet is a misdirection, something loud and obvious, drawing attention. While the real reconnaissance happens closer to Earth, Project Galileo is watching for that. 3 observatories are scanning the skies, looking for an increase in unexplained phenomena around the time of perihelion. If it's there, the data will show it. And underneath all of this, the scientific community is divided, not publicly. Not in press releases, but in the quiet spaces. Some insist it's an unusual, but natural, comet. Others look at the data and cannot make it fit. Cognitive dissonance is becoming a professional problem, according to the leaks, and the silence from leadership is growing louder. A proposal has been made. UNIO, the United Nations Committee on Interstellar Objects, a framework for international coordination. The Webb scale is the official classification system, protocols for rapid response, observational networks, even a spacecraft ready to launch on short notice. When the next visitor arrives, because the next one is coming, observed, Vera Rubin ensures that an interstellar object every few months, maybe more, and each one is an opportunity or a warning. BAI Atlas is currently at a 6 on the Webb scale, high enough to warrant a serious investigation, not high enough to trigger emergency protocols. But if the predictions hold, if gamma rays are detected, if the trajectory changes, if the activity continues, the rating will rise and the conversation will escalate. We are about to learn something in the next 3 months, maybe sooner. The data will arrive and either confirm the conventional explanation or force us toward alternatives. Mars imagery will show whether the nucleus is large or small. Spectroscopy will refine the chemistry. Orbital measurements in December will reveal if anything happened behind the sun. The gamma-ray searches will either find a signal or rule it out. The Galileo project will either detect an increase in UAPs or it will not. And in the spring, when BAI Atlas passes Jupiter and Juno gets a close-up look, we will have a comprehensive data set, enough to say with confidence what this object is, or at least what it is not. The universe does not lie. It does not hide its secrets forever. If BAI Atlas is just a comet, a strange comet, but a natural one, the data will converge on that answer. The anomalies will be resolved. The models will be adjusted, and we will move on. But if the data continues to refuse to cooperate, if each new observation adds another layer of strangeness, if the pattern of anomalies persists and deepens, then we must follow where it leads. Even if it is uncomfortable, even if it challenges everything, we think we know about what drifts between the stars, because that is the promise of science, not comfort, not certainty, but the truth, no matter how strange it may be. Thank you for listening, for staying with this story through all its twists and uncomfortable questions. If you found this valuable, please press the like button and subscribe if you have not already. It helps more than you know. And in the comments, let me know. Are you convinced that this is just a comet? Or is there something here that doesn't fit? What do you think we are looking at? This video is for entertainment and educational purposes. The views expressed, especially those regarding the 4-page paper and the speculative theories, do not represent the scientific consensus. Always consult peer-reviewed sources and official statements from space agencies for verified information. Until next time, keep watching the skies, because there is something out there moving in the dark. And in a few short months, we will know a little more about what it is. Good night.